In this video, I am explaining about moments. Moments are used to describe the characteristics of a distribution. So, they are used to describe characteristics of any distribution. So what do you mean by characteristics of distribution? Characteristics of a distribution means where the data is centered, that is central tendency, how data is scattered, that means dispersion, and symmetry of the data as well as flatness of the data, that is called as shape of the data. So characteristics of any distribution is nothing but knowing about the central tendency, center value, then knowing about the scatteredness or dispersion, then about shape of the data, shape of distribution. So about is it a symmetric distribution or is it knowing about the flatness of the distribution. So that is called as characteristics of distribution. These statistical measures can be summarized using the concept of moments. These moments give some features of the given frequency distribution. Moments can be termed as information about the whole distribution using a single concept. That means this single concept moments gives you the information about central value, dispersion, as well as symmetry, as well as flatness. This is what the significance of defining moments in statistics. Now let us see types of moments. There are basically two types of moments. The first one is raw moments and the second one is central moments. So raw moments are measured about any arbitrary point. So these are measured about any arbitrary point A. Whereas central moments are measured about the mean. About the mean, arithmetic mean. In raw moments, again we can have moments at origin. Moments at origin. That means here the moments are measured with respect to the origin or 0. So they are called as moments about the origin. So you can define it as three types: moments at any arbitrary point, then moments about origin, then moments about the mean. But basically when we are segregating, we say that there are two moments, raw moments and central moments. Raw moments are measured about any arbitrary point A. So if raw moments are measured about origin, then they are called as moment about the origin. Then if the moments are measured about the mean, then we call them as central moments. There are basically four important moments. We call them as first moment, second, third, and fourth. These are the very important moments. These moments are represented using the symbol mu. Raw moments are represented as mu dash and central moments are represented just mu. Therefore, initially there is a 0 moment, that is nothing but represented as mu naught. In the case of raw moments, here raw moments, here you will have the 0 moment mu naught dash, then first order moment mu 1 dash, second order moment mu 2 dash, third order moment mu 3 dash, fourth order moment mu 4 dash, so on up to rth order moment mu r dash. So raw moment or moment at origin, they have mu dash, that is the representation. Now central moments are represented as mu naught, 0 order moment, mu 1, mu 2, mu 3, mu 4 and so on, mu r. So these are central moments. This is the notation. You have to remember raw moments and moments at origin are represented with a dash, central moment just with the sign mu. Out of these moments, first, second, third and fourth order moments are very important. They play a significant role in knowing the information about the data. Now let us see the methods of calculation of moments. That is the formula to calculate moments. The first type is how to calculate moments about any arbitrary point A. So it is given by the formula mu r dash means this is rth order moment. Rth order moment. So moment about any arbitrary point or moments about origin are denoted with the mu with a dash. So mu r dash equal to summation I equal to 1 to n xi minus a to the power r divided by n. This is for ungrouped data. This is called as rth order moment. R equal to 1, 2, 3 and so on. So if you want the zeroth order moment, so mu naught, it is denoted as mu naught dash equal to anything to the power 0 becomes 1. So it is always equal to 1 about any arbitrary point or about origin or about mean. If you consider in any case, mu naught dash is always equal to 1, which is called as zero order moment. So now let us find out the first, second, third and fourth order moment. They are of importance in the statistics. Mu1 dash is summation I equal to 1 to n xi minus a power 1 divided by n. Mu2 dash is summation I equal to 1 to n xi minus a whole square divided by n. Similarly, mu3 dash, mu4 dash you can calculate to the power, raise it to the power 3, then raise it to the power 4. You have to substitute the value of r accordingly. Now, if you have grouped data or data with the frequencies, then the rth order moment about arbitrary point A is given by mu r dash summation I equal to 1 to n fi into xi minus a to the power r divided by capital N, where capital N is sum of all frequencies and this capital A is any arbitrary point. Now let us find out moments about origin, that is when a equal to 0. So your mu r dash becomes, put a equal to 0 either in this formula or this formula. So mu r dash becomes summation I equal to 1 to n xi to the power r divided by n, because a becomes 0. So therefore mu r dash with the frequencies is summation I equal to 1 to n fi into xi power r divided by capital N. So let us find out first order moment. Mu1 dash, put r equal to 1, summation of xi I equal to 1 to n divided by n. Mu2 dash is xi square, sum of all these xi squares divided by n. Mu3 dash is xi cube, here it is xi power 4. Now when you look at this mu1 dash, it is nothing but the formula of mean. Sum of all observations by number of observations gives you mean. So mu1 dash is equal to mean. This is how you calculate moments about origin. Just you have to put a equal to 0. Next is about moments about mean. Let us see how to do that. Suppose if you want moments about mean, so that is here a equal to x bar. So the formula becomes rth order moment is summation I equal to 1 to n xi minus x bar to the power r divided by n. This is for ungrouped data. Ungrouped data. Then for a grouped data or data with the frequencies, so I equal to 1 to n fi into xi minus x bar to the power r divided by capital N. So where n is the capital N is the sum of all frequencies. So based on this, suppose if you want the first order moment mu1 equal to, zeroth order moment is always equal to 1 because anything to the power 0 is 1. Now if you want mu1, then it becomes summation I equal to 1 to n xi minus x bar to the power 1 divided by n. So we know that the algebraic sum of all these deviations is always equal to 0. So mu1 equal to 0. So mu2 equal to summation I equal to 1 to n xi minus x bar whole square divided by n. The same will apply for the data with the frequencies. Here also the same case. So this is nothing but variance. This is variance. because the formula of variance, square of deviations, sum of squares of deviations divided by total number of observations. Mu3 equal to summation I equal to 1 to n xi minus x bar to the power 3 by n, and mu4 equal to summation I equal to 1 to n xi minus x bar whole power 4 divided by n. So here this is direct formula of variance. This becomes equal to 0. So therefore I can write here mu1 equal to 0 and mu2 equal to sigma square. So whenever you are calculating moments about mean, the first order moment is 0 and the second order moment is variance. Therefore the first order moment, mu1 tells you about the mean, mu2 tells you about the variance, then mu3 tells you about the skewness, that I will define later how to calculate the skewness using mu3, and mu4 will tell you about the kurtosis. So all in terms of a single concept called as moments. Therefore, moments are used to define the characteristics of a given distribution. Now let us see shortcut method to find moments, that is to find moments about any arbitrary point A. This will help you to reduce the time for calculation, because in the usual method you have to find out xi minus a to the power r for each and every first order, second order, third order or fourth order moments. You need to do separate columns for all that. So instead of that, you can calculate di, the deviations given by xi minus a divided by h, where h is width, h is distance between the given two points. And rth order moment is given by mu r dash. Rth order moment is given by mu r dash equal to summation I equal to 1 to n di to the power r divided by n into h to the power r. This is for ungrouped data, and for grouped data or data with frequencies, mu r dash is summation I equal to 1 to n fi into di to the power r divided by capital N into h to the power r. This is the formula shortcut method to find the moments about any arbitrary point. So using this method, we can calculate the moments about any arbitrary point. Later, if you want moments about mean, then we have the relation between these two moments. Using that, we can calculate the moments about mean. I will show you how to do that. Now about relation between raw moments and central moments. Raw moments are nothing but they are moments about any arbitrary point. Central moments are moments about origin. So central moments are denoted as mu1, mu2, mu3, mu4 like that, and raw moments by mu1 dash, mu2 dash, mu3 dash, mu4 dash. So in the previous case, I have already told you, I have already explained how to get the moments using shortcut method. So this is the method to find the raw moments. Once the raw moments are obtained, then to get the central moments, we have the formula, that is the relation between these two moments. Mu2, the central moment, second central moment is given by mu2 dash minus mu1 dash square. This is second raw moment minus first raw moment square. Anyway, first central moment is always equal to 0. We have already seen that mu1 equal to 0. So we are starting with mu2. Mu2 equal to mu2 dash minus mu1 dash square. Similarly, mu3 equal to mu3 dash minus 3 mu2 dash mu1 dash plus 2 mu1 dash cube. Mu4 is mu4 dash minus 4 mu3 dash into mu1 dash plus 6 mu2 dash into mu1 dash square minus 3 mu1 dash to the power 4. So you have to memorize this relation to obtain the central moments from raw moments. So remember it like this, mu2, so after the first term there is always one mu1 dash, okay, and the last term always ends with the value here, subscript 2, so its power will be 2 here, mu1 dash power is 2, mu3 here, so power of mu1 dash is 3. Here mu4, so power of mu1 dash is 4. And alternative positive and negative term Coefficients you have to remember. There are no coefficient, means coefficients equal to 1 here. Here 1, 3, 2, then 1, 4, 6, 3. So this is the relation between raw moments and central moments. Now about Pearson's beta and gamma coefficients. So beta 1 is given by mu 3 square divided by mu 2 cube. This is in terms of moments. This beta coefficient is used to measure the skewness. But this is just a numerical value. This doesn't give you the direction of skewness. That is obtained using the gamma coefficient. Gamma 1 equal to plus or minus square root of beta 1, which is nothing but mu 3 divided by sigma cube. Because here mu 2 cube to the power 1 by 2, because taking the square root means square root cancels, you will just get mu 3. Here mu 2 to the power 3 by 2. We know that mu 2 is sigma square, so square cancels, you are remained with the sigma cube. So this is called as coefficient of skewness, that gives you the direction of skewness as well. Now similarly beta 2. So beta 2 is given by mu 4 divided by mu 2 square. This is to measure the kurtosis. So coefficient of kurtosis is given by gamma 2, which is equal to beta 2 minus 3. So these things you have to remember. The measure of skewness and measure of kurtosis is done using the beta and gamma coefficients. So we make use of the concept of moments to find out the beta and gamma coefficients. So whenever we are saying the skewness, gamma 1, the coefficient of skewness is a better measure because it gives you the direction of skewness. Now let us solve one problem. For the following distribution, calculate first 4 moments about mean. Also find out beta 1, beta 2, gamma 1, gamma 2. Karl Pearson's beta and gamma coefficients. And here they have asked you have to find moments about mean. So you have to find out central moments. So to get central moments, first let us find out raw moments. Then we shall make use of the relation between raw moments and central moments to get the central moments. So first let me write here marks, then it is frequency. So marks 5, 10, 15, 20, 25, 30, 35. Then we need frequency. Frequency is 4, 10, 20, 36, 16, 12 and 2. See here mu r dash is given by summation I equal to 1 to n fi into di to the power r divided by capital N. N is sum of all frequencies. So here capital N equal to, when you take the sum of all frequencies, you will get this value as 100. Add all these values. Now you need to get di. Di is given by xi minus a divided by h, where h is the width. Here from one data point to another data point, the difference is 5 for each data point. So h is equal to 5 here. Then a is assumed mean, some arbitrary point. I am taking a as assumed mean. You have to assume randomly here the central value for this data. So just look at the data which is central value. Quite easily you can identify the central value is nothing but 20. I will take that as a assumed mean. So this is equal to a equal to 20. Then we have to find out xi minus a. So di equal to xi minus a by h. This is that column we need after frequency. So xi is here 5 minus 20 divided by 5. It is like this, 5 minus 20 divided by h is 5. So this gives you minus 15 by 5, which is equal to minus 3. So for the first one it is minus 3. Similarly you have to do it for second one. That is 10 minus 20, that is minus 10 by 5 minus 2. Then here 15 minus 20 minus 5 divided by 5, which is minus 1. 20 minus 20, it is 0. Then here 25 minus 20, which is 5 by 5, 1. Then 30 minus 20, 10 by 5, which is 2, positive 2 now. Then last it is 3. So this is di. Next I want fi into di, this column. We want the first 4 moments. So first 4 raw moments, mu1 dash I want, which is summation I equal to 1 to n fi di divided by capital N. Mu2 dash is equal to summation I equal to 1 to n fi di square divided by capital N. Similarly, mu3 dash I want, then mu4 dash, which that means fi di I want, then fi di square I want, then fi di cube, then fi di power 4. So fi di, let us find out that first. 4 3 is a minus 12. Then 10 2 is a minus 20 with a minus sign. 20 into minus 1 minus 20. 36 into 0 0. 16 1 is a 16. 12 2 is a 24. Then 3 2 is a 6. I need the sum of this fi into di. That gives you, you take the algebraic sum, which gives you minus 6. Now I need fi into di square. Okay. So first you have to get di square. Minus 3 whole square is 9. 9 4s are 36. Then minus 2 whole square is 4. 4 10s are 40. Then minus 1 whole square is 1. 120 is a 20. Then here anyway it is 0. Next 1 square is 1. 16 ones are 16. 2 square is 4. 12 4s are 48. Then 3 square 9. 9 2s are 18. When you take the sum of all this, you will get the value 178. Now similarly I need fi di cube, then fi di power 4. So fi di cube, di cube, d1 whole cube, that is minus 3 whole cube, which is nothing but minus 27. Minus 27 4s, that gives you minus 108. Then similarly minus 2 whole cube minus 8. 8 minus 8 into 10 minus 80. Similarly minus 20, calculate one by one. This comes out to be 0. This is 16. This is 96 and 54. So when you take the sum of all this, you will get equal to minus 42. Then di power 4 minus 3 whole power 4, it is 81. 81 4s, 81 4s value is 324. So similarly minus 2 whole power 4, 16. 16 10s, 160. Then similarly minus 1 whole power 4, 1 into 20, which is 20. Next is 0. Next is 16. This is 192 and this is 162. So when you take the sum of all this, we will get it as 874. Now let us substitute all this here. So mu1 dash is calculated as, this is divided by n into h square and so on. So mu1 dash is equal to, this is the formula. This is the formula. We got minus 6 divided by 100 into h is 5. So this gives you the value minus 0.3. Similarly mu2 dash is equal to 178 divided by 100, because sum of fi di square is this 178 by capital N is 100 into 5 square. H is 5 square is 25. So when you simplify this, you will get 44.5. Then similarly mu3 dash is equal to summation of fi di cube divided by capital N into h cube, which is minus 42 divided by 100 into 5 cube, 125, which is equal to minus 52.5. Similarly mu4 dash equal to minus sigma fi di power 4 by n into h power 4. This is equal to, we got the sum of last column, 874 divided by 100 into 5 to the power 4, which is 625. So this gives you the answer 5462.5. These are all raw moments. That is moments about any arbitrary point. So we got mu1 dash as a point minus 0.3. This is mu2 dash. Then we got mu3 dash and this is mu4 dash. Now using these four, I have to find out moments about mean or central moments. Mu1 equal to 0. Mu2 equal to mu2 dash minus mu1 dash square, which is equal to mu2 dash is 44.5 5 minus mu 1 dash square is minus 0.3 square. This is equal to 44.41, which is nothing but sigma square variance. Similarly, we need mu 3 is equal to, so mu 3 equal to mu 3 dash minus 3 mu 2 dash into mu 1 dash plus 2 mu 1 dash cube. This is the formula. So, as per the formula, substitute all the values here and finally we will get minus 12.504. Similarly, mu 4 equal to mu 4 dash minus 4 mu 1 dash into mu 3 dash plus 6 mu 2 dash into mu 1 dash square minus 3 into mu 1 dash power 4. So, substitute all these values here. Mu 4 is 5462.5, then this is 5462.5 minus 4 into minus 0.3 into minus 52.5 plus 6 into 44.5 into minus 0.3 square minus 3 into minus 0.3 to the power 4. So, after simplifying, we will get 5423.50. So, this is mu 4. Now, we got all 4 central moments. Mu 1 is anyway 0, mu 2 is variance, which we got it as 44.41, mu 3 is minus 12.50, mu 4 is 5423.50. So, we need now beta and gamma coefficients as well. So, beta 1 equal to mu 3 square by mu 2 cube. So, mu 3 is this value. Now, don't look at this raw moments, we have to see the central moments. Mu 3 square is minus 12.504 to the power 2. Mu 2 is 44.41 whole cube, which is equal to, we will get the value as 0.001785. Similarly, gamma 1 equal to, so we know the formula, mu 3 by sigma cube, which is equal to minus 12.504 divided by 6.6641 cube. So, that gives you the value minus 0.0422. Beta 2 is mu 4 by mu 2 square. So, mu 4 is 5423.50 divided by mu 2 is 44.41, its square. So, this gives you the value 2.7499. Then gamma 2 equal to beta 2 minus 3. So, this gives you 2.7499 minus 3, which is equal to minus 0.2501. So, this is how to obtain the beta and gamma coefficients. Now, see the second problem. The first 4 moments of a distribution about the value phi of a variable are given here. So, you have to find the central moments. These are raw moments because about the arbitrary value here 5. So, here given mu 1 dash is equal to 1, mu 2 dash is equal to 10, mu 3 dash is equal to 20 and mu 4 dash is equal to 25. You have to find out central moments. They are nothing but mu 1, mu 2, mu 3, mu 4. Then you have to find out beta 1 and beta 2. So, mu 1 is equal to mu 1. So, mu 1 is always equal to 0. So, you have to start with mu 2. Mu 2 is equal to mu 2 dash minus mu 1 dash square. So, which is equal to mu 2 dash is 10 minus 1 square, that is equal to 9. Next, mu 3 is equal to mu 3 dash minus 3 into mu 2 dash into mu 1 dash plus 2 into mu 1 dash cube, which is equal to mu 3 dash is 20 minus 3 into mu 2 dash is 10 into mu 1 dash is 1 plus 2 into mu 1 dash cube, 1 cube, which is 1. So, this is equal to 20 minus 30 plus 2, which is minus 8. Similarly, mu 4 I want. Mu 4 is equal to mu 4 dash minus 4 into mu 3 dash into mu 1 dash plus 6 into mu 2 dash into mu 1 dash square minus 3 into mu 4 dash to the power 4. Mu 4 dash, mu 4 is 25 minus 4 into mu 3 dash is 20 into mu 1 dash is 1 plus 6 into mu 2 dash is 10 into mu 1 dash square is 1 minus 3 into, so this is mu 1 dash to the power 4. So here 3 into minus 3 into mu 1 is 1 to the power 4. So after simplification, this gives you final value 2. So we got all 4 central moments. Now we need beta 1. Beta 1 is equal to mu 3 square divided by mu 2 cube. So mu 3 is minus 8 whole square divided by mu 2 is equal to 9. So 9 cube, which gives you 64 by 729, that is equal to 0.0877. Similarly, beta 2 equal to mu 4 divided by mu 2 square. Mu 4 is 2 divided by mu 2 is 9. 9 square is 81. So this gives you the value 0.0247. So this is how we find first 4 central moments and beta 1 and beta 2. Now third problem, for the following distribution find central moments and beta 1 comma beta 2. So here this is a grouped data where the class intervals given. The only difference here is you have to find out the midpoint, that is the extra column you have to put. Here class given, then frequency given, then you have to find out the midpoint of the class interval, that is xi, this is fi. So here it is 1, 3, 7, 3, 1. So midpoint of 1.5 to 2.5, add these two, 1.5 plus 2.5 divided by 2, that is 4 by 2, that gives you 2. Similarly here this is 6 by 2, this is 3. Then in this case 4.5 plus 3.5, 8 by 2, that is 4. So 2, 3, 4, 5, then 6. These are the midpoints. Then in the same way as you have done for the ungrouped data with the frequencies, the same method you have to follow. First you have to find out raw moments. They are nothing but mu r dash is equal to summation I equal to 1 to n fi into di power r divided by n into h to the power r. So this gives you the raw moments. After getting the raw moments, you have to find out mu 1, mu 2 using the relation. Mu 1 is 0, mu 2 is mu 2 dash minus mu 1 dash square. Then mu 3 is mu 3 dash minus 3 mu 2 dash into mu 1 dash plus 2 mu 1 dash cube. Mu 4 is mu 4 dash minus 6 into mu 3 dash into mu 1 dash plus 4 into mu 2 dash into mu 1 dash square minus 3 into mu 1 dash to the power 4. So using these formula you have to get the central moments. I will not do it once again, the same procedure. Here you need to find out di as xi minus a divided by h. So assumed mean, you just look at the points. Here assumed mean could be taken as 4. So assumed mean is 4 because just look at the points. There are 5. If there are 5 points, then you have to take the midpoint as the assumed mean, that is 4. Then h is very easy here, width equal to 1. Therefore this term just gets simplified to xi minus a. So no term in the denominator as it is 1. So you have to get di here, which is nothing but 2 minus 4 minus 2, 3 minus 4 minus 1, 4 minus 4 0, 5 minus 4 minus 1, 6 minus 4 2. Then we need the sum of all these frequencies. Sum of all frequencies is 15. Then we need Fi into di, Fi di square, Fi di cube, then Fi di power 4. So Fi into di. So that is minus 2, 3, minus 1 is minus 3, 0, minus 3, 2. I need this sum. Similarly, di square, minus 2 whole square, 4. 4 ones are 4. So 3 here, then 0, then it is 3, then it is 4. This sum I want. Similarly, this would be minus 8, minus 3, 0, 3, 8. This is 16, 3, 0, 3, 16. So I need these sum. So in this case, the algebraic sum is 0. Here it is 14. Here it is again 0. Then in this case, you will have 38. So using all these values, you have to substitute it in this formula. So that means here it becomes mu 1 dash is equal to summation I equal to 1 to n Fi into di divided by n into h. That will not be there because 1 to the power any value 1. Mu 2 dash is equal to summation I equal to 1 to n Fi into di square divided by n. So mu 3 dash is equal to summation Fi di cube divided by n into h cube. That term won't be there. 1 cube is 1. Mu 4 dash is equal to summation Fi di power 4 by n. Substitute all values here. It is anyway mu 1 dash is equal to this sum we got it as 0. So mu 2 dash is equal to 14 by 15. Mu 3 dash is equal to 0 and mu 4 dash is equal to 38 by 15. This gives you 2.533 and mu 2 dash, this simplification gives you 0.93. So once you got obtained all these values, substitute in this formula to get mu 2, mu 3, mu 4 and similarly you find out beta 1 and beta 2 using the formula. So this is how we define moments, and there are raw moments and central moments. Raw moments are calculated about any arbitrary point and central moments are calculated about mean. To calculate central moments, first we need the raw moments. Using those raw moments, we will make use of the relation between raw and central moments. We will substitute those raw moments in this relation to get the central moments using the shortcut method. Otherwise, that becomes a very lengthy process to calculate the central moments. So instead of that, we calculate the raw moments using shortcut methods. Then we use the relation between raw and central moments to get the central moments. This is all about moments. I hope you understood the concept. Thank you for watching.